Now the second part of the question is to calculate the displacement. Now let's see what we're given. We're given delta D1, which is 160 kilometers an hour east, and now we calculated this in our previous question when we took 80 kilometers an hour east and we multiplied it by 2 hours. Now we have delta D2, which is 180 kilometers south, and we calculated this when we took 60.0 kilometers an hour and multiplied it by 3 hours. And lastly, we have T1, which is 2.0 hours, and T2, which is 3.0 hours. Now, what's required of us is displacement. Now, displacement can be represented by delta dt with an arrow on top. Now, analysis. This is where we would write our formula. Now, to calculate displacement, the formula is delta dt equals delta d1 plus delta d2. Now, let's go to our solution. Now, it would be, we use the same formula, bring it down. So, delta dt with an arrow on top equals delta d1 plus delta d2. Now, let's put our values. We have 160 kilometers east added by 180 kilometers south. Now, looking at this question, we cannot just add these two values because looking at the directions, we have east and we also have south, which makes it impossible for us to add them the way it is. So what we do is we use Pythagorean theorem. But before we do that, let's draw our vector diagram. Let's draw our compass: north, south, west, east. So from this, we can draw our vector diagram. First, we're traveling 160 kilometers east, and then 180 kilometers south. So delta D1 is 160 kilometers east, and delta D2 is 180 kilometers south. What we're looking for is the dashed line, just the distance over here, which we will just call it the delta D total. Now, using Pythagorean theorem, the formula is a squared plus b squared equals c squared. Now, where a and b is, that's where we're going to put our values. So a is 160 in brackets squared plus 180 in brackets squared equals c squared. Now we would calculate this. 160 squared, that gives us 25,600 plus, and we calculate 180 squared, and this gives us 32,400, and this equals c squared. Then what we do is we take these two values and we're going to add them. So when we add them, we have 58,000 equals c. Square root of 58,000 equals c, because I just took out the square and made a square root. Now when we calculate this, square root of 58,000 this gives me 240.83189. Now it's okay to keep the decimal places because later on we're going to then figure out the correct number of significant digits. Then what we do is we want to find the angle. We want to find this angle over here. So we're going to go tan theta is opposite over adjacent. We will rearrange tan so that theta equals tan inverse of opposite over adjacent. And then we'd put in our values. Our opposite value is 180 and our adjacent value is 160. And when we calculate this, we're going to get a value that's greater than 45 degrees. So we get 48.4 degrees. However, we cannot, anything over 45 degrees is unacceptable. So all we have to do is we go 90.0 degrees subtracted by 48.4 degrees. And this will give us 41.6 degrees. And now this represents this angle over here. This is our new angle because we subtracted it from 180. So now let's look at significant digits. So we have 2 significant digits here, 2 significant digits there. So that'll give us 2 significant digits, 2 significant digits. Now when we add these two together, our lowest place value is in the thousand column. So that gives us 2 significant digits. And so then when we square root it, we'll still get 2 significant digits. That means we have to cap it right there. So our final answer would mean that you have 240 kilometers, 41.6 degrees. Looking at this diagram, it's east of south. And then we would write our therefore statement. Therefore, the displacement is 240 kilometers, 41.6 degrees east of south.